Friends, welcome to the class. Today we'll discuss about areas of sector and segment of a circle. Friends, already we learned about this sector and segment of the circle. First of all, we have a small recap and then afterwards we'll discuss some practical question. So let's start. The region enclosed by two radii and corresponding arc of a circle is called sector of a circle. In the given picture, OAPBO is a sector with sector of the circle with center O. Here AOB is called angle of sector. This particular angle is called the angle of the sector for this particular sector. The sector containing minor arc is called minor sector and the sector containing major arc is called major sector. Now how to find the area of the sector? Let there be a circle of radius r having minor sector with angle theta. So area of the sector is given by theta by 360 degree into pi r square. That means theta by 360 into total area of the circle. So area of the major sector is pi r square minus area of the minor sector. That means total area of the circle minus minor sector. Area of the minor sector gives the area of the major sector. Area of the minor sector is pi r square minus area of the major sector. Length of an arc of a sector. The arc corresponding to a sector is called arc of the sector. If the radius of the circle is r and angle of the sector is theta, then the length of the arc equals to theta by 360 degree into 2 pi r, or it is also written as area of the sector in terms of length of the arc equals to 1 by 2 into LR. L represents length of the sector. Segment of a circle. The region bounded by a chord and corresponding arc of the circle is called segment of the circle. In the given picture, the yellow marked region, that means region APB, is a segment of the circle. The segment containing minor arc is called minor segment and the segment containing major arc is called major segment. Now how to get area of the segment? Area of the segment equals to area of the corresponding sector minus area of the triangle formed by the chord and the radii of the circle. Here APB is a segment. How to get this area? First of all, we have to find out the area of the total sector OAPBO. Total sector minus area of this triangle AOB will give the area of this segment APB. Area of the major segment equals to pi r square minus area of minor segment, and area of the minor segment equals to pi r square minus area of the major segment. Let's see some examples. The length of the hour hand of a clock is 7 cm. Find the area swept by the hour hand in 1 hour. The hour hand of a clock describes the circle of radius equal to its length, that means 7 cm in 12 hours. Why in 12 hours? Because the hour hand makes a complete rotation in 12 hours. So once it completes one rotation, that will represent a circle. And what is the radius of the circle? It is 7 cm, which is nothing but the length of the hour hand. So the angle described by the hour hand in 12 hours equals to 360 degree, or the angle described by the hour hand in 1 hour is 360 degree by 12, which is 30 degree. So the area swept by the hour hand in 1 hour is the area of the sector of angle 30 degree in a circle of radius 7 cm. That we got r, the radius of the circle, and also we got theta, the angle of the sector. So the record area is theta by 360 degree into pi r square, which is nothing but 30 degree by 360 degree into 22 by 7 into 7 into 7, which is 12.83 centimeter square. Hence, the record area is 12.83 centimeter square. Area of a sector of a circle of radius 36 cm is 54 pi centimeter square. Find the length of the corresponding arc of the circle. Given that the radius of the circle is 36 centimeter and area of the sector is 54 pi centimeter square. We know area of a sector in terms of length of arc is 1 by 2 into L into R. So we can write 54 pi equals to 1 by 2 into L into 36, or this implies L equals to 2 into 54 pi whole divided by 36, which is nothing but 3 pi. Hence, the length of the corresponding sector is 3 pi centimeter, is the answer. A cow is tied with a rope of length 14 meter at the corner of a rectangular field of dimension 20 meter into 16 meter. Find the area of the field in which the cow can gaze. Let's draw the picture first. So, as it is clear from the picture, the length of the rectangular field is 20 meter and width is 16 meter, but the cow is tied with a rope of 14 meter. And this particular angle, since the cow is tied in a rectangular field, this particular angle is 90 degree. Given that the angle of the sector theta equals to 90 degree and the radius of the circle is 14 meter, the cow can gaze a field equivalent to a quadrant of the circle of radius 14 meter, because this represents 1/4 of a circle. Since theta is 90 degree, this represents 1/4 of a circle. So it is nothing but the cow can gaze the area which is equivalent to a quadrant of a circle of radius 14 meter. So area of the sector is theta by 360 degree into pi r square, or it is nothing but 90 degree by 360 degree into 22 by 7 into 14 into 14, which is nothing but 154 meter square. That means the cow can gaze a field of 154 meter square, is the answer. In a circle of radius 28 centimeter, an arc subtend an angle 45 degree at the center. Find the length of the arc and using it find the area of the sector. Given that radius, which is r, equals to 28 centimeter and angle of the sector theta equals to 45 degree. Now length of the arc is theta by 360 degree into 2 pi r, or we can say it is 45 degree by 360 degree into 2 into 22 by 7 into 28, which is 22 centimeter. We know that the area of the sector in terms of length of the arc is 1 by 2 into L into R. So area of the sector is 1 by 2 into 22 into 28, which is 308 centimeter square. That means the length of the arc is 22 centimeter and the area of the sector is 308 centimeter square, is the answer. A chord of a circle of radius 20 centimeter subtend an angle of 90 degree at the center. Find the area of the corresponding major sector of the circle. Friends, here we need to take one thing into mind. Whenever we come across any sector or segment, it is always we are talking about the minor segment or minor sector. If it is specifically mentioned, find the area of the corresponding major sector, then we have to find out the minor sector and we have to subtract the area of the minor sector from the total area of the circle. If this particular word major sector or major segment is not mentioned, then by default we have to find out only the area of the minor sector or minor segment. Let's go for solving it. Given that the radius of the circle r equals to 20 centimeter and the angle of the sector theta equals to 90 degree. Now area of the sector is given by theta by 360 degree into pi r square. So the area of the sector is 90 degree by 360 degree into 3.14 into 20 into 20, which is nothing but 314 centimeter square. Now the given sector is a minor sector because theta equals to 90 degree and theta, the value of theta is less than 180 degree. So the area of the major sector is nothing but pi r square minus area of the minor sector. That means total area of the total circle minus area of the minor sector, which is nothing but 3.14 into 20 into 20 minus 314, which is nothing but 1256 minus 314, or it is equals to 942 centimeter square. Thus, the area of the major sector is 942 centimeter square, is the answer. Find the area of the segment shown in the picture if radius of the circle is 21 cm and angle AOB equals to 120 degree. Let's draw the picture first. So in this picture we have to find out the segment AYB. Here it is given angle AOB equals to 120 degree and the circle of the radius of the circle AOB equals to 21 cm. So given that R equals to 21 cm and angle AOB equals to 120 degree. Now area of the sector OAYB equals to theta by 360 degree into pi r square, or it is 120 degree by 360 degree into 22 by 7 into 21 into 21, which is nothing but 462 centimeters square. Now area of the triangle AOB equals to 1 by 2 into base into height. See friends, in order to find this area of this particular segment, we need the area of the total sector and we need the area of this particular triangle individually. The area of the total sector minus area of the triangle will give the area of this particular segment. We already obtained the area of the sector, which is nothing but 462 centimeter. We need the area of this particular triangle AOB. So here area of the triangle AOB is 1 by 2 into base into height, but only we know the base. Height is not known to us. When base is also not known to us, only we know the two sides at 21 centimeter. Let's find out. Let OM is drawn perpendicular to AB such that OM is drawn such that OM perpendicular to AB. Let's draw the picture. So OM is a perpendicular drawn on AB. Now angle OMB equals to angle OMA equals to 90 degree. Now in triangle OMA and triangle OMB, we have angle OMA equals to OMB, which is both equals to 90 degree. OA equals to OB, both are the radius of the same circle, and OM is common side. That means triangle OMA is congruent to triangle OMB. So both the triangles are congruent to each other. So we have angle AOM equals to angle BOM, or we can say angle AOM equals to angle BOM equals to angle AOB whole divided by 2, which is nothing but 60 degree, because this angle AOB is 120 degree. And both the angles, angle AOM and angle BOM, are same. So both are equals to 60 degree. Also AM equals to BM, or we can write AM equals to BM equals to AB by 2. This is first equation. Now in triangle OMA, sin 60 degree equal to AM by OA. See, if we take in triangle OMA, if we take this angle to be the angle of reference, then sine of angle O or sine of angle AOM, which is nothing but sine of 60 degree, is nothing but perpendicular by hypotenuse MA by AO, or it is nothing but root 3 by 2 equals to AM by 21, or this implies AM equals to 21 root 3 whole divided by 2. Now in triangle OMA, cos 60 equals to OM by AO, again the same thing. If we take this to be the angle of reference for cosine or cos theta, it is cos theta equals to OM by AO, or this implies 1 by 2 equals to OM by 21, this, or OM equals to 21 by 2. Now from equation 1 we have AB equals to 2AM, because in equation 1 AM equals to twice of AB by 2, so AB is twice of AM, or this implies AB equals to 21 root 3, 2 into 21 root 3 by 2, which is another 21 root 3. So area of triangle AOB equals to 1 by 2 AB into OM, base into height, or this is equals to 1 by 2 into 21 root 3 into 21 by 2, which is nothing but 441 root 3 whole divided by 4. Now we got the area of this triangle, and area of this complete sector is known to us. So now we can find out the area of this segment. So area of the segment AYB equals to area of the sector OAYB minus area of triangle AOB, which is nothing but 462 minus 441 root 3 by 4, or on taking 4 as LCM, it is 1848 minus 441 root 3 whole divided by 4 centimeter square. So the record area is 1848 minus 440 under root 3 whole divided by 4 centimeter square is the answer. Friends, here is a few questions, few examples. Practice more and more such questions, and in case you come across any difficult question, feel free to share it with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your question. We'll discuss some more questions in the coming class. This much for today. Thank you.